Hi, I'm Yasra, and I am going to present my work on uh, reaction time as a proxy for presence in mixed reality with distraction. Mixed reality application is expanding beyond leisure, and the rich connection between the physical and virtual world offered by mixed reality makes it an ideal technology for safety-critical applications such as surgery, construction. While user being immersed in fully present environment is required for all application, it is especially important for critical applications where the simple distraction actually can harm the user. Let's understand the presence first. It is a subjective feeling of being in a place or environment. A user who is present in an environment can respond to a visual cue as if it is real. And the environment could be purely physical, purely virtual, or the combination of both, like we have it in mixed reality. And the high level of presence is desired. However, to improve presence, we must understand what factors influence presence, and we must be able to quantify that. Traditionally, presence have been gauged mainly through subjective questionnaires and after the fact, and it often produces unstable responses and there is no reproducibility. Behavior and physiological responses are mainly susceptible to bias and can often have unreliable and noisy data, and sometimes are heavily sensitive to the environment. So, as we know, there are multiple drawbacks to traditional presence measure. We come up with a proposal of reaction time as a presence measure. And the reaction time or response time is the time it takes for a user to respond to a cue. And the hypothesis we have is that the user takes longer to respond to a cue if they are not feeling present in an environment than a user who can actually immediately respond and react. Reaction time as a measure satisfies many of the desired properties, such as it is objective, quantitative. It also doesn't require any intervention that will actually cause distraction or break in presence. We don't have any causal link between the presence and reaction time, but my work has established a negative correlation between presence and reaction time, which means that the higher the presence, the lower the reaction time, and vice versa. Presence in mixed reality can influence by a wide range of factors. On one hand, we have technical factors like realism of the environment, details in the environment, and plausibility. And on the other hand, we have human factors such as agency, lifelong habits, genetic predisposition, and conditioning. There are other factors which are also affect presence, like interaction, the bystanders around you, or the physical environment, some distraction that happened in the physical environment. And my works look at how the presence and alternative human performance-based presence measure like reaction time actually interact with each other, and what are the aspects that how when we alter the presence impact the reaction time or not. Mixed reality operates at the intersection of user physical surrounding and the virtual objects. To create immersive experiences, they must accurately track the user position and adapt with the environment and interpret interactions. And any of these can actually cause cognitive overload or physical risk. The first two tasks are mainly related to where the user is, like what is the use, what are the physical objects around the user, how physical interactions are being made, and is there any distraction in the room, like somebody physically entering the room where the user is actually experiencing a virtual reality. And the last question is actually about how the user is interacting with this environment, how familiar the user is, how the visual objects are arranged, how the interaction is designed, and so on. In today's talk, we are going to focus mostly on the distractions that happen in the physical environment and how the user surrounding and human behavior changes based on that. So first, before we go further, I'll give you a background about types of distraction. Distraction could be of mainly two types, congruent and incongruent. Congruent is basically when the distraction actually happens within the visual environment, such as like a secondary task, like somebody asks you to actually push a buzzer. Or incongruent is where the real world stimuli actually happens and physically user have to disconnect from the visual environment and do the interaction outside of the virtual environment, like someone asking to pass a glass. And then we could talk about, I'm going to talk about break in presence. The Break in presence is the moment when the user shifts the attention from the virtual to real world by that it can be caused by some distraction that happened in the real world or virtual world, like some that could also be happening by some system lag, some delays that are happening for the tracking, some jitters that are happening in the systems. Anything can cause the break in presence, or some tasks which are very heavily loaded with a lot of virtual objects that can actually cause cognitive overload. And the impact is that it actually reduces the experience, which is presence, and it also slows down the user, and it can manifest as reaction time being slowed. So the major question that we ask in this paper is, how do the different distraction types, whether they are created in the virtual environment or real environment, actually influence breaks in presence? And what is the relationship between the cognitive load, reaction time, and presence when distraction alters the experience? So to explain that, we have a cognitive distraction model. So what it says is that distraction actually cause break in presence. In an ideal mixed-reality environment, a user remains fully immersed in virtual environment. However, the distraction, whether virtual or real world, can interrupt that immersion. When that happens, the user experiences a break in presence. BIP. Break in presence also increases the cognitive load. Once the user attention shifts away from the virtual environment, they must process additional sensory information. This increases the cognitive load, requiring mental effort to refocus on the task. And the last part is like higher cognitive load leads to a slower reaction time. As cognitive load increases, reaction time slows down, and users take longer to process and respond to a stimuli because their cognitive resources are divided between handling distraction and maintaining the presence or attention to the virtual task in mixed reality. So to answer our question, we decided to experiment with two types of distraction, congruent and non-congruent. And for that, we created three conditions. No distraction is the baseline, where we have undisturbed primary task, and the congruent and non-congruent have a secondary task. One is that where we have a virtual disturbance, and the other one we have a physical distraction added to the virtual task. So we see that there is a different aspects of cognitive load, reaction time, and presence that we expect to happen. And we have, so for the task we have as a primary task, we ask user to actually sort images in between living and non-living. And for the second task, we introduce a buzzer that needs to be turned off by the pressing a button. In the cognitive distraction, which is where we are introducing the distraction within the virtual environment, there is a yellow virtual button that the user needs to press. In the incongruent, we are asking the user to actually press a button outside of the virtual environment. The red button here is actually a physical buzzer that the user needs to press. And in no distraction, on the left, we have a no distraction task. In the middle, we have congruent distraction, and in the right, we have incongruent distraction task. We conducted a within subject to user study with three conditions, and we designed two distraction patterns to make sure that the user is not anticipating the distraction, and we alternatively applied that to either the congruent or incongruent for a particular user, and we use the counterbalancing to actually minimize the learning and fatigue of the efforts. And we had in each condition set, we had 30 trials. So while our paper present a detailed analysis of the findings, here I show a few key results. Across conditions on the left, we show the presence scores measured through their presence and reaction time. We show a modest negative correlation, which means that when the presence is increasing, the reaction time is going to go down. On the right side, we see presence and cognitive load are also negatively correlated, which means that when the presence is going down, the cognitive overload is going to go up. Lastly, I would like to conclude my talk with this mediation analysis that shows break in presence influence reaction time and cognitive load, and presence is a potential mediator. Here we show that the BIP and break-in presence slows down the reaction time, and while the cognitive load doesn't significantly mediate this effect, presence play a crucial role, indicating that the user experience more break-in presence, their immersion drops, and leading to a delayed response. With that, I conclude my talk.